Hi everybody, it's Professor Burns here, and I wanted to do a short video, and I may break this into two videos just so it's not quite so lengthy, but a couple of questions on the Unit 1 review before the test that I think would be particularly good for you to look at just in preparation for the test. So make sure you know, let me go back to Canvas for just a second, make sure you know that the test is due on Tuesday, I believe. Yeah, June 3rd by midnight. So you want to make sure you start it by 11 o'clock that night. Don't wait till the last minute is my recommendation, but no later than 11 o'clock because it will cut you off at midnight, 11:59 p.m. on Tuesday. So to make sure you get that full hour, make sure you start by 11 o'clock. But in the modules tab, under, I think this was in week 2 module, the test number 1, review and information, there are a bunch of worksheets here that I use during the regular fall and spring semesters that are really, really good reviews for the test. So I highly recommend that you download these and work through them as you study and get ready for the test. I believe I've included solutions to all of them, but this Unit 1 review in particular, it has solutions at the end of it, but this is a really thorough review. If you feel comfortable with the questions on this Unit 1 review, then I think you're probably in pretty good shape for this first exam. So what I thought I would do is go over a few things that I want to make sure you feel comfortable with, that I specifically thought would be good to look at for the test. So let me go ahead, let me get back to my tablet software. And like I said, make sure you have paper out, make sure you see where I'm getting these questions from. So this is from that Unit 1 review. And the first thing I want to make sure you're comfortable with is understanding the different types of variables. So this was back in Chapter 1 at the very beginning. One of the first things we talked about were that you either have variables that are categorical or numerical. And those are the two types of variables we work with in this class. So on a question like number 1, they're giving you a chart with a bunch of data. You don't need to know the difference between stacked and unstacked. I don't think there's a question like that on the test. I'll go back and look. If there is, I can throw it out later. Don't stress about that. I never remember the difference. But what I do want you to be clear is how to read the table itself. That's the most important thing. So if you look at a table like this and you see that there are how many questions, for example, that were asked in a given survey. So in this question, or in this survey rather, we were asked their gender, their commute, their hair color, their ring size, their height, the number of aunts they have. This is kind of a silly survey. The number of units acquired in college, I guess that'd be like credit hours, and their living situation. So that would be the variables. How many variables are there in the survey? So we asked 1, 2, 3, 4, 5, 6, 7, 8 questions. That means there were 8 variables that we accounted for. So the first question, how many variables? There would be 8. There are observations on how many people. Observations is another word for like how many people or how many items or how many sea turtles, whatever it is we're talking about, did we collect data on. So observations is the number of things we collected data on. So in this table, you can see we go by row. Each row represents a different individual in the survey. So if you count up how many rows there are, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means there were 11 observations or 11 people that we surveyed in this example. You may also see that as the sample size. So we could say this is the sample size in this case was 11. That's another thing we might mention. Now, are the variables numerical or categorical? So make sure you're comfortable on the difference here. Numerical are essentially variables that you can do arithmetic. Ask yourself, does it make sense to find an average? So commute distance, if I said, is there an average commute distance for the students in this sample? If I could add these numbers up and take the average, that means I'm dealing with numerical data. Let me go through the questions they asked. They said living situation. Living situation refers to some sort of quality or classification. So whether you lived in a dorm or you were a commuter student, that was your living situation. So that means that this would have been categorical data. The commute distance, let me go back to that for a second. Can I find the average number of miles students in this sample commuted? And I can, so that means that is numerical data. number of ants. I guess I could ask, what's the average number of ants for students in this survey? Again, those are numbers. We could average those together, so that would be numerical. Number 4, ring size. This one's maybe a little bit tricky. I think you could actually argue this one either way. Could we find an average ring size? I would go with numerical in this case. If I said, could I average these numbers together and get an average ring size for students? I would say yes. So I would go with numerical. Ring sizes are a bit limited in that you're either a 6 or a 6.5, kind of like shoe sizes. Although I think in one of the videos I had an example where I had shoe sizes and I said it was numerical. Technically, I think that would be categorical because we would limit. You're a 6 to, or a 6.5 or a 7. It's a finite number of options for the ring sizes. I digress. I don't want to get everybody confused. I think in this case, we could say ring size is numerical. I might have said categorical in the answers, but if you say numerical for that, that's fine. Don't worry about that one. Hair color though. Hair color, you either in this case, they had black, brown, or blonde. Those are classifications or descriptions. So that certainly is categorical. And then height would be an average of height. I could figure that out. There's a range of numbers people could give me for their heights. So I would certainly say that that is numerical. And then the last thing in this question, they said how many females are represented in the sample data. This data is coded so that you are either a 1 or a 0 depending on whether you're a female or you're not a female. So in this case, if you were a female, you were coded as a 1. If you were not a female, you were coded as a 0. So if we count up how many 1s there are, 1, 2, 3, 4, 5, it looks like there's 6 1s. So I would say there were 6 females represented. So just make sure you're clear on how to read that coded data. The next question I wanted to look at was question number 7, and that's the difference between an observational study and a controlled experiment. And again, this goes back to chapter 1. Let's just make sure we're clear on what the difference is between those two things. So an observational study is where the data, remember, is already out there. I'm pulling the data. I'm comparing existing groups. I'm pulling data and comparing the data that I pulled. That would be an observational study. A controlled experiment is where we randomly assign people to either a control group or a treatment group. Generally, those are going to be some kind of a medical study, although you can do a medical study that's an observational study. That is possible, but controlled experiments are almost always going to be medical studies in general, although there can be others. But the thing with the controlled experiment is that the subjects have to be assigned by the researchers in some way to either a control or a treatment group. If the groups already exist, then it's it's an observational study. So number 7, it says patients with high blood pressure are asked to keep food diaries recording all items they eat for a 1-week period. Researchers analyze the food diary data for trends. Is this an observational study or a controlled experiment? Now, they did not say that they assigned participants to one group or another. There was no treatment. There was no placebo. They literally just said, record what you eat. We're going to pull that data. So they took the data and looked for data trends. So that means that we're looking at an observational study there. Number 8, on the other hand, says patients with multiple sclerosis are randomly assigned. So when we assign to one group or another to either get a new drug or a placebo, and then are given a test of coordination after 6 months, that would be a controlled experiment because the researchers assigned everybody to one group or the other. So when people are assigned, that's going to be your controlled experiment. The next thing I wanted to look at were reading graphs and making sure we're comfortable with making sure we can read graphs for data that's either numerical or categorical. Let me skip down to number 12 here. This is a dot plot, so make sure you remember the different types of graphs that go with different types of data. That's going to also be very important later on in the semester when we get to our project. So make sure you remember that when we're dealing with numerical data, we either use a dot plot or a histogram. And I don't remember in the video, I might have mentioned something called a stem plot. I can't remember. Stem plots are a little bit hard to analyze, so we don't use them quite as often. Dot plots and histograms are the two main ones that go with numerical data. Categorical data, on the other hand, we only have two options we're going to use for categorical data, and those are bar graphs and pie charts. So just make sure you know which types of graphs go with which type of data. And by the way, you can use an index card on the tests in this class. You can make an index card, a 3x5 card. You can put whatever you want front and back. So any formulas or definitions or something like this that you think you might forget, put that on your index card. This might be a good thing to jot down. All right, so let's take a look at number 12 and make sure we're comfortable reading this. So we're looking at a dot plot, which means we're looking at numerical data, and they're giving us resting pulse rates for a group of 125 people. Okay, many sources say the resting pulse rate should not be more than 100. Okay, so question A says, how many of the 125 people had resting pulse rates of more than 100? And be careful when you read this. If it says more than, we mean more than 100. That means don't include 100. If we wanted to include 100, we'd say 100 or more, or 100 or greater, or something like that, or greater than or equal to 100. It just says more than 100. So I'm not going to include the people that are right at 100. I'm only going to include the ones that are greater than that. So it would be these two here, these two here. So I would say that would be 4 people in this group. And then B says what percentage of the people had resting pulse rates of more than 100. So same thing, those 4 people, they want me to just convert that to a percentage. Remember how to do a percentage? That would be the part over the total. So I'm going to take 4 and I'm going to put it over 125. And then I'm going to put that into my calculator and get a decimal value. So make sure you have a calculator for the test. That's very important. You cannot use your cell phone. So please, please, please get a calculator. Don't handicap yourself by going without. So in my calculator, I get 0.032. So convert that to a percentage by moving it 2 spaces to the right or multiplying it by 100. And I get 3.2%. So about 3.2% of the sample had a pulse rate of more than or greater than 100. Now, number 13, we are looking at a histogram. I know it's a histogram because the bars that are there are bins, by the way, are touching each other. Remember, with bar graphs, they have to be separated. So I've got a histogram and it says the number of calories in a sample of fast food items. So number of calories would be numerical data. So it has to be a histogram or a dot plot. So we know it's a histogram here. And it says, what is the bin width? So the width is literally just like it sounds. How wide is each little bin? How many calories does each bin go? And with histograms, generally the bin widths should be equal. I can't think of a scenario where they wouldn't be. So just go ahead and take a look at your graph and let's figure out. It looks to me like this is labeled 200 here, and then 400, and then 600, and there's a line in between. So it looks to me like each one has a width of 100. And remember too that when you're talking about each bin, it's the number on the left endpoint up. So in other words, this first bin would start at 100 and go up to, I guess, like 199. The next bin would go, this group here would be 200 up to, say, 299. And then, assuming we're not counting half calories or anything like that, the next bin would be 300 up to 399. So whatever number is at the left endpoint is where that bin starts. B says, would this graph be best described as unimodal or bimodal? This is a little bit subjective. I would say this is probably bimodal because you've got two bins that are close in height. Yeah, I would say bimodal. If this second one were a little bit shorter, then I would say it's probably just unimodal. But I would go with bimodal for this one. Also notice that, and it didn't ask this question, but notice that this is right skewed. Remember, wherever the tail is, that tells you the shape of the graph. Because the tail's on the right side, it's right skewed. Part C says approximately what percentage of the fast food items contained fewer than 300. So fewer than 300 mean that they want me to count the first two. So I've got, let's see, if this is 300, they want me to count this bin, and the video is going to cut me off. So hang tight and I'll finish in the next video.